In this video, we will cover the outer two giant planets, Uranus and Neptune, and then briefly explore objects in the Kuiper belt, including Pluto, which is now classified as a dwarf planet. So the video begins with a view of the orbits of the terrestrial planets, and then now we're moving outwards to the region of the giant planets. Uranus is an orbit that's about 20 times as far from the Sun as the Earth, and Uranus is the first planet that was discovered with a telescope. So the next planet out, Neptune, is about 30 times as far from the Sun as the Earth, and Neptune was discovered from mathematical calculations developed to explain the motion of Uranus. So we will begin the visits by going to the planet Uranus, and we'll see images from spacecraft flybys of the planet, and you can notice the color of the planet is this interesting blue-green color that you'll see as we approach the planet, giving the views from these spacecraft images. And there is also a very thin ring structure surrounding the planet. So you can notice that now. You see the circulation pattern of the atmosphere, and it's moving with the planet rotation. And this gives you a view that Uranus has an unusual spin axis that is actually pointed towards the Sun rather than perpendicular to the Sun and perpendicular to its orbit. Now we see a cartoon cutaway view of the planet with three main components. And the outermost region is showing the hydrogen-helium gas atmosphere, and then that layer is over two denser regions. Next, we'll visit the planet Neptune. So as we move away from Uranus, we'll be approaching Neptune. And again, you should notice the circulation pattern on the atmosphere and search for this even thinner ring arc structure that is most visible below the planet in this view. And so the belt zone circulation is parallel to the equator. The spin axis of Neptune is more similar to the other planets. And the storms that you're seeing on Neptune have been monitored over several year timescales, and they've been noticed to change over that sort of time. The ring arcs were very faint, and then now we're going and looking at the cartoon cutaway view. Again, those same three regions where the gaseous envelope covers an ice rock layer, and then the core is made of a heavy element core. So because of that structure, these planets, Uranus and Neptune, are sometimes called ice giants, and they are different in their overall structure from Jupiter and Saturn. Now we're approaching Pluto, and starting with a simulated view of this dwarf planet, and you see many craters on the simulation, and we'll see how that compares to actual satellite imagery of Pluto. So the New Horizons spacecraft made a flyby of Pluto, and what you're seeing next will be the actual images from the New Horizons spacecraft. So as you look at these real images, you notice that there are far fewer craters than expected from that simulated view, and you see this heart-shaped structure that's about 1,000 miles across, and it's very smooth without craters, indicating that it has a young surface. And this was a real surprise to realize that Pluto had ongoing geologic processes that would create that sort of surface feature. So now we're moving outwards into the Kuiper belt. The blue orbit is that benchmark of Neptune. The white orbit is Pluto, and you see how Pluto's orbit is much more inclined than Neptune. And those are four other dwarf planets in orange orbits, again very inclined and much more eccentric. And now as we move outwards, we'll investigate the orbits of other Kuiper belt objects, and you see that again they have higher inclinations compared to the inner solar system and much more eccentric orbits. This widest orbit is from the object Sedna, which has an aphelion, or farthest from the Sun distance, of 900 AU.